In this video, I intend to show you how to determine whether a sequence is arithmetic or geometric. Recall that arithmetic means you're adding or subtracting, and geometric means you're multiplying or dividing. So the first thing I'm going to check is see if we can find a common difference or common ratio. Let's start first by subtracting. So what we're going to do is subtract each subsequent term by its previous term. So we'll start with 6 minus 3. That would give me 3. Then we try 9 minus 3. That's also 3. Then we have 12 minus 3, which is also 3. We have 15 minus 3, which is also 3. We have 18 minus 3, which is also 3. So we have a common difference. So this is an arithmetic sequence. In our next example, we're given the sequence 3, 6, 12, 24, 48, and 96. So first thing we want to check is see if we have a common difference. So we're going to check 6 minus 3. That's 3. 12 minus 6 equals 6. So we don't have a common difference. So we want to check for a common ratio. So we're going to try 6 divide 3, which we know is 2. 12 divide 6, which we know is also 2. 24 divide 6, which we know is 2. 48, 12 divide 24 divide 12 is 2. 48 divide 24 we know is 2. And 96 divide 48 is 2. So we have a common ratio of 2. So it's a geometric sequence. Common ratio 2. The next section of the video, I want to talk about evaluating sequence in recursive form. In the first example, we're given a sequence that is an arithmetic sequence, and we're given a formula. So recall that a(n minus 1 just means previous term. So it says find the first 4 terms. So we already know a1. That's 4. We want to find a2. So what we're going to do is we're going to find a1 plus 3.2. We know that a1 is 4 plus 3.2. That's just 7.2. a3 gives me my previous term a2 plus 3.2. So that'd be 7.2 plus 3.2, which just gives me 10.4. A4 will be the previous term, A3 plus 3.2. Which we know is 10.4 plus 3.2, which we know is going to be 13.6. So my first four terms would be 4, 72, 7.2, 10.4, and 13.6. My next example gives a geometric sequence in recursive form. So recall Gn minus 1 is just means previous term. So again, we want to find the first four terms. So the first term is given to us as 10. So we want to find the second term. So that'd be G2, which is just the previous term G1 times 1/2 or 1/2 G1. Just do it the same way the problem's written. 1/2 times G1, which is 10, and half of 10 is 5. G3, that would be half of the previous term, which is just half times 5. So that'd be 5 over 2. For G4, that's 1/2 times the previous term, which is 5/2. So that's going to be 5 over 4. So my first four terms would be 10, 5, 5/2, and 5/4. The next recursive formula is a little bit different. It's neither arithmetic or geometric. It's a sequence that we're giving a first term and we're given a number divided by the previous term. So let's see how this one works out. So it's, again, we're trying to find the first four terms. So we know H1 equals 14. H of 2 is going to be 28 divided by the previous term, because recall when we see that n minus 1, it just means previous term. So I'm going to do 28 divided by 14, which equals 2. Then we'll find h of 3. So now we're going to do 28 divide 2, which is 14. H of 4 is going to be 28 divided by the previous term again, which is 28 divided by 4, which is 2. So your first four terms are going to be 14, 2, 14, and 2, and there's your first four terms. The next sequence, we're given two terms, and we still want to find the third and fourth terms. So we know the first term is -6. The second term is -4. So f of n minus 1 means previous term. This is the term before the previous term. before the previous term. So to find f of 3, what we want to do is first f of n minus 2, we would have f of 1 plus f of 2. So in this situation, f of 1 is negative 6 plus negative 4, which gives me negative 10. We have f of 4, which would be two previous terms ago. So it'd be f of 2 plus f of 3 equals f of 2 we know is negative 4. F of 3 is negative 10, so we end up with negative 14. In the next section of the video, I'm going to talk about how to determine from a situation if we're multiplying or dividing to use, or adding or subtracting to use an arithmetic or geometric sequence. So the problem we're given is Muhammad decided to track the number of leaves on the tree in his backyard each year. The first year, there were 500 leaves. Each year thereafter, the number of leaves was 40% more than the year before. Let f of n be the number of leaves on the tree in Muhammad's backyard and the nth year since he started tracking it. Determine the sequence as arithmetic or geometric. Whenever we see a percent, we know we're dealing with an geometric sequence because you can't add a percent. So we want to keep this in mind. Percents indicate geometric. It's a geometric sequence. Write an explicit formula and recursive formula for the sequence to determine how many leaves will be in Muhammad's backyard after 5 years. So let's first write the explicit formula. So that would be just f of n equals, the starting amount will be 500. The common ratio, since is going to be, first we have to convert that percent to a decimal. So that would be just 40 divided 100, which gives me 0.4. So it'd be 1 plus 0.4 to the n minus 1, which just simply reduces the 500, parentheses 1.4 to the n minus 1. Now the recursive formula. So that will give me f of 1 equals 500. And then f of n equals the first term, or the previous term, which is f of n minus 1 times 1.4. And we have our recursive formula with those two elements. Now, it says, determine how many leaves will be in Muhammad's yard after 5 years. So keep in mind, it will be very challenging to use the recursive formula since we already know the explicit formula. So what we're going to do is we're going to plug in the 5 into the explicit formula. I'm going to say f of 5, since we're talking about 5 years, equals 500 times 1.4 to the 5 minus 1. Now from here on out, it's just simplifying. So it'll be 500 times 1.4 to the fourth power. And now just use a calculator to find out what that is. So in the calculator, we just type it in just the way you see it. 1.4, close it, up to 4. And we have approximately 1,920.8, or we'll round it to 1,920 leaves. And we're done. Last example. Seo Yun hosted a party. She had party favors, 50 party favors to give away, and she gave away 3 party favors to each of her friends as he arrived. Let G of M be the party favors Seo Yun had before the nth guest arrived. Determine whether it's an arithmetic or geometric sequence. So since we're giving away party favors, that indicates giveaway indicates subtraction. So this, in fact, would be an arithmetic sequence. Now, write an explicit formula for the recursive sequence and write an explicit formula and recursive formula for the sequence and determine when there will be 0 party favors. So first, we're starting with 50, and we have 3 party favors to give away to each guest. So let's start with the explicit rule. So that would be G of n, since we define as G of n, equals 50, which is my starting amount, minus 3 and minus 1. Then we have the recursive formula. That would be G of 1 equals 50, and then G of n equals G of n minus 1 minus 3. Now it says determine when there will be 0 party favors. Since this would require some algebra, it would be easier to use the explicit formula again. So we'll set the explicit formula equal to 0. So we're going to say 0 equals 50 minus 3 and minus 1. So first thing we have to do is get rid of this 50. So we're going to subtract 50 from both sides. You have negative 50 equals negative 3 and minus 1. Next, distribute. So we have negative 50 equals negative 3 and negative 3 times negative 1 will be positive 3. Now, subtract 3 from both sides. So subtract the 3, subtract the 3. And we have negative 53 equals negative 3n. One more step. Divide by negative 3. Divide by negative 3. Plug it in the calculator. And we end up with n equals 17.7. So we're going to round that to be, since we're talking about guest, she would have 0 party. We couldn't round up to 18 because she wouldn't have enough party favors. So we would say after the 17 guests can get 17 guests. you have to round down. Hopefully this will help you with the assignments that you have this week using Khan Academy. Good luck. Email me if you have any questions.